All right, students, welcome to another day of ratios and proportions. Hopefully yesterday wasn't too hard learning that cross multiply process, and that if you've got a proportion, then the cross multiplications are equal, and hopefully that helped out. We're going to do a little bit more with our ratios and proportions today, finding out if something is proportional, and then determining what you can do with that proportion. So just remember, proportions are simply two fractions that are equal to each other. That's it. And so today we're going to do a little bit more with that, finding out if things are proportional or proportions, and then that helps us know how to use them. So we'll dive right in. Here we go. The worksheet that exists there that you've got, it's the back side if you were in class when we did it, but it's also available there. I've got that posted for you. And what this is asking is, each of these, are these a proportion? State if each pair of ratios, state if these two fractions, do they form a proportion? Basically, write an equal sign over the word and see if it's true. So if I say equal and equal, is 2 over 4 equal to 12 over 16? And that's what we're doing on these problems. Are they equal? Well, there's a couple ways to tell. One way is that cross multiplication way we learned yesterday. So 4 times 12, that's 48. Does that in fact equal 2 times 16? You can use your calculator if needed to get 32. Are those, those are not equal, so no, that is not a proportion. If you do a few of these, the next one, 3 over 2, is that equal to 12 over 8? Well, just 2 times 12. Make them equal as an equation, and 3 times 8 from our multiplication. Yes, those are equal. So yes, that one is a proportion. 8 over 4, is that the same as 4 over 2? Are those two equal? You can multiply them like we've been doing. Another way is to see how are those two related, and then are these related the same way? Let's see, this is 8 cut in half makes 4. 4 cut in half is 2. So yes, that is a proportion. On this one, that's kind of hard to tell on this one. It's maybe hard to see that this is 2 times 1.5 to that. So you can cross multiply, like we've done before, make an equal sign. Another option is with this 3. What did I multiply 3 by to get 15? And on that one, I multiplied by 5. So you multiply 2 by 5, and do you get the same thing? No, you don't. It's not the same thing. The cross multiplication gets you 18 equals to 30. So there's another way to tell that it's not equal. I'm just showing you multiple ways to tell whether or not they're equal. You're just comparing the numbers in the same way. To get from 3 to 9, to get from there to there, you multiply by 3. So the question is, if you multiply 4 by 3 to get the same, oh, no, you don't. You don't get the same thing. So in multiplying that, that's times 4 and times 3. So no, that is not a proportion. If I'm throwing too much at you and doing too much, just remember the cross multiplication. See if when you cross multiply, you get the same thing. 9 times 4, that's 36. 16 times 3, that's 48. Those are not equal. Multiplying these, 6 times 4 is 24. And 2 times 12 is 24. So yes, that is a proportional relationship. You're wondering if these are basically the same fraction. Yeah, that's 1/2 and that's 1/2. Yeah, they're the same fraction. So are these two the same fraction? That's what you're asking. Is 3/4 equal to 9/8? You may already see an answer there. If you multiply, cross multiply, 3 times 8 is 24, and 4 times 9 is 36. Nope, those are not equal. So work through these, see if they're equal fractions. If you can see these numbers and see them for what they are, that number is less than 1 and that number is greater than 1, that would work. Or to get from 3 to 9, you times 3. So on 4 to 8, did you times by 3? No, you didn't. No, you only times by 2, so it's not. And on this one, 12 times 2, that's 24. 4 times 3, that's 12. Those are not, so no. So you can work through these. That's the first part of today's activity. Are they proportional? Can you see whether they're proportional? This is one way to look through it. Go through each of these and see if they are. When you get ones like this that are hard to decipher, you can use your calculator. Sometimes you can also reduce these. And you can see that on each of these, 2 goes into them, so that becomes 24 over 14. Oh, and 2 goes into each of those, so that's the same as 12 over 7. So is 8 over 7 the same thing as 12 over 7? No, those are two different fractions. I'm kind of jumping around a bit just to show you some different ways to see this. You can, like we did yesterday, you can research, is it proportional? How to tell if a fraction is proportional, and there's just a lot of ways to compare those fractions. Another way to compare fractions to find out if it's proportional is through tables. You might see them compared in tables. And so I've got a bunch of tables written out. The question is, are those proportional? And it's the same way. You can look at these as though they were a fraction to see if they are proportional. Well, how is that a fraction? Well, you can put 240 over 3, make it a fraction, and see if when you divide that, you get the same thing as 400 divided by 5 or 720 divided by 9. You can divide these in the same order, 240 by 3, 400 by 5, 720 by 9. You could do it the other way. You could do 3 over 240. Just as long as you set up the fraction the same way each time, you can check and see if they're proportional. So whether you type those 3 in your calculator or these 3 in your calculator, do you get the same number? That's what it's asking. You get the same number. And yes, you do. If you type it in this way, you get the answer of 80 each time. So you know they're proportional. If you type them in the other way, 3 divided by 240, for example, 3 divided by 240, you get 1/80th or 0.0125. And you get that each time you put each of those in the calculator. So yes, that is a proportional relationship. And you can do that anytime you get a table. When you divide these, do you get the same thing? And you'll usually see it written as, let's write it over here. You'll see it written as y divided by x. So when you divide 5 by 2, or 7.5 by 3, or 12.5 by 5, or 18 by 8, do you get the same fraction? So for example, 5 divided by 2. 5 divided by 2, and I get a number. And then 7.5 divided by 3, I get a number. And then 12.5 divided by 5, do I get the same number? And finally, 18 divided by 8, you want to check them all. Whoa, what's that? 18 divided by 8, I didn't get the same number. So is that a proportional relationship? Are those all the same thing? No, they're not. Because I did not get the same number each time I divided them. Those are not all the same fractions. It was close, but they're not all the same fraction. What if I give you these slices of meat and I said, are they proportionally related? If I have 166, will 2 of them be that, and 3 of them be this, and 4 of them be this? When they don't tell you, y is usually the second number. Again, you can divide in any order, but on this, I'm going to do 66 divided by 1, 96 divided by 2, 126 divided by 3, and 156 divided by 4. So are those proportional? Do I get the same number each time? To make this easier, 66 divided by 1, and then I'm going to do 96 divided by 2, and 126 divided by 3, and 156 divided by 4. And then I'm going to see, do I get the same number each time that I divide those? I do not. So that is not a proportional relationship. No. And you can kind of see that 166s, that's not the same as 2 somethings to get 96. When you cut that in half, you're definitely not going to get 66. On this one, are these proportional relationships? If you divide the y the y divided by x. If you get 64 by 4, 125 by 5, 216 by 6, 1000 by 10. Are those going to give me the same numbers? And if so, what would this number be for 11? You can take a minute and pause the video if you want to see if these are the same numbers. 64 divided by 4 is 16. 125 divided by 5 is 25. 216 divided by 6 is 30. I think it's 36. And 1000 divided by 10 is 100. So no, none of those are the same. That is not, so we can't even determine what 11 would be. There's no way to do it because they're not a proportional relationship. None of these are turning out to be proportional. And what about this last one? Eggs, eggs costing that much money. I'm going to do the 21 divided by 6 and the 28 divided by 8 and the 35 divided by 10 and the 49 divided by 14. Do those all give me a proportional relationship? Yes, they do. Yes. So if that's the case, then I can determine any one of these. I can come up with anything. Right? 21, I can figure out what that other one is because they're all related in a 3.5 times way. Okay, so when you see tables, you can look and see if there's a proportional relationship. It's just like a fraction. Just imagine on all of these, it's just like it's a fraction. In class, we found some recipes online. We're going to find some recipes online. And then we know that recipes are proportional. So if the recipe will feed 20 people, then how much would we need to feed 60 people? And we can create a proportional relationship. That's just more of an in-class activity with something fun. But if you want to search up your favorite food, the recipe for your favorite food, and then look at what's required to serve, let's say 20 people, you can then, we call the word extrapolate. We can work out how much would you need to serve 60 people. You could create that proportion if you desire. The assignment today is to do, it's there in Savvas Realize. I don't need to talk about the assignment because you can just move to the assignment page in today's activity and take a look at the assignment there, but it's 2-3. So is it proportional? Make proportions. Can you create proportions? Can you solve and decide whether or not it's proportional? That's the work for today. Thanks for watching and have a wonderful day.